Hello everyone. So we are going to discuss question 2 in embedded C. The question is, how do you decide if two integers have opposite sign? Dealing with sign integers is not straightforward, and one has to be very careful while dealing with integers which are not declared as unsigned. So the thumb rule is, if there is no requirement of signed integers, you should better use unsigned integers, because signed integers, unless necessary, might end up in creating bugs. Okay, now coming back to the topic or the question, how do you decide if two integers have opposite sign? So let us go deeper in understanding nine integers. So as we know that binary numbers have only two possible values, 0 and 1. For sign, there is also 0 and 1 used. For example, if sign is positive, the most significant bit of that number is 0, and if the sign is negative, then the most significant bit of that number is 1. So I'll just put it down here. With this understanding, let's move forward. One dedicated bit is assigned to a sign number, so it basically reduces the range of that number that can hold the maximum value by half. So if you compare the capacity of signed integers to that of unsigned integers, it is half of the unsigned integers, because one bit is utilized for the sign and rest of the bits for the magnitude. Okay, positive numbers are stored in memory as it is without any change. But negative, what about negative numbers? Negative numbers are stored in memory in 2's complement form. Okay, I am expecting everyone is aware of this 2's complement concept, and it is the basics of electronics engineering. So, with that assumption, we will move forward. So, for negative numbers, there is one more criteria, that is MSB of negative numbers is always 1, and negative numbers are stored in memory in 2's complement form. So, with this knowledge, let's go a little deeper in understanding what all combinations we have when we want to compare two integers. We have below combinations of signs for two signed integers. One number is positive, other number is negative. Then MSB, sign bit is not same for both the integers. Both the numbers are positive, MSB is 0 for both the integers. Both the numbers are negative, then the sign bit is 1 for both the integers. This will help us in finalizing the logic to decide the sign of integers. So everyone, I hope, aware of XOR operation, and it is always bitwise. The output of XOR operation is 1 only if bits are not same. For example, 0 XOR 1 is equal to 1, or 1 XOR 0 is equal to 1. Whereas the output of XOR operation is always 0 if both the bits are same, either 1 or 0. So 1 XOR 1 is 0, 0 XOR 0 is 0. If we XOR two integers of opposite sign, then MSB is 1, that is negative number. If we XOR two integers of same sign, the MSB is 0, that is positive number. Now we can write the code, the actual code, as we have finalized the logic. This is how code looks like. I have declared two integers, signed integers x and y, assigned some initial value to them. If result of XOR between x and y is less than 0, then numbers have opposite sign. So this is how we can finalize the logic. But to finalize that logic, we have to have this understanding And with this understanding only, we are able to come to this final logic. Okay, let us run this code. So numbers have opposite sign. Suppose if I keep sign for both the numbers as same, so they don't have opposite sign. In this case as well, numbers have opposite signs. So this logic is proven, and we can finalize this logic. Thank you.